Okay, welcome back, everybody. This next session is on understanding dam safety inspections, and this is going to be a two-part session. And the first part will be on inspection letters and forms. And George, I will turn it over to you, and please remember to introduce yourself.
Perfect. Thank you, Tony. And hello, everybody. My name is George Kaiser. I'm a civil engineer. I work as a dam safety engineer with the Oregon Water Resources Department Dam Safety Program. My background is in structures and structural analysis. I'm going to be going over understanding dam safety inspections and looking at our process for those inspections. Can everybody see the screen okay? Is my PowerPoint showing up?
Yep, I can see it, George.
Okay. All right, so a little bit on dam safety inspections and the frequency. This was mentioned a little bit earlier in the presentation, but high hazard dams are inspected annually. Significants are inspected every 3 years, and low hazard dams are inspected every 6 years. The estimated number of dams inspected annually is 76 high hazards, 52 significant, and 119 low hazard dams. And the total number of state regulated statutory dams in the state of Oregon. So we've got 76 high hazards, 154 significant hazard, and 709 low hazard dams. On the right-hand side of the screen here, you can see a map just kind of showing the location of some of these state-regulated dams. The yellow dots are the significant hazard, the red are the high hazard, and the blacks show location of low hazard dams. We've seen this slide a little bit earlier, but just going over a refresher on terminology. And I'll go through this kind of quick since we've already seen it. So looking at the crest of the dam or the top of the dam. And of course, behind your dam is your reservoir. The upstream slope of your dam faces your reservoir, and the downstream slope faces away from your reservoir. We have the principal spillway, also called a drop inlet riser, sometimes called a trickle tube inlet. Not labeled on this illustration, but shown, you can see this pipe that is traveling through the embankment from the principal spillway to the outlet works. So this would be your low-level conduit. The conduit outlet, this is showing a stilling basin, and then downstream of the stilling basin is your discharge channel. Here we're seeing the emergency spillway, also called the auxiliary spillway. And then your abutment contacts where the embankment is in contact with the natural grade adjacent to the dam. So during the inspections, we're going to go through each one of these features of the dam, and each one of those features will be given a rating. That rating is on a scale from 1 to 5, and it's based on the condition of that particular feature. And just going over the rating system. So 5 is associated with an exemplary condition. So typically this is something that's very new, or it might be something that's very well maintained. A 4 is probably the most common rating. So that's our default rating, and it means it's adequate. There's no concerns noted. A 4 minus, it would be a minor maintenance needed. So this is something to where there's something on the dam that needs to be addressed, but it's not to the point of needing a maintenance action yet. But if not addressed, it may become a maintenance action in the future. A 3 rating. There's something on the dam that is not quite a safety concern yet, but will become one in the future if it's not addressed. And then we have a 2, which is a corrective action, and a 1. And so a 2 would typically mean there's a potentially unsafe condition, whereas a 1 would be an unsafe condition. And the next portion of this presentation will go a bit deeper into what a maintenance action is and what a corrective action is. So when we come out to the dam to do the inspection, we're going to be completing the inspection form. We'll collect all the information that we need on that form, and we'll bring it back to the office, and we'll put together a inspection letter. Typically, we try and get those inspection letters turned around in about 30 days after the inspection is completed. Taking a closer look at the inspection form and zooming in on the upper portion here, we're going to state the name of the dam, the height of the dam, and the storage. We'll state the reservoir permit number, our file number. We'll give the hazard rating of the dam, and we'll let you know if we're going to request a hazard rating review if we notice something that maybe it should be a different hazard rating. We'll state the water master district where the dam is located, the date of the inspection, the weather conditions at the time of the inspection, the date of the previous inspection. We'll state who the primary inspector was and then anybody else that was on site as well. And we'll include some information from prior inspections if there was any maintenance action needed that we'll be looking at. And you can see here again too on the inspection form that rating criteria is stated again. So the first couple of features that we're looking at, we'll look at vehicle access and general conditions downstream of the dam. So we're looking for any structures, infrastructure downstream of the dam that may be new or existing, approximate distance from the dam downstream. Looking at vehicle access, what type of access it is. We're going to be looking at the reservoir. So here you can see the pool level. So this is the elevation of the water surface at the time of the inspection. And in this case, you can see we've approximated it from the crest. And so reading this, this would be saying that your pool level was 4 feet below the crest at the time of the inspection. And then we will also give an estimate on the minimum freeboard. And so this is minimum freeboard in recent history that was observed on the dam. And then any conditions within the reservoir that may or may not be an issue. And so you can see here where we look at floating debris or trash, is there a log boom installed, or any other unusual conditions. And so some examples of vehicle access. You can see on the left-hand side, we have an asphalt-coated driveway that leads to the crest of the dam. And so this would be a rating of 5. It's very well maintained and fairly new access to this dam. And you can see on the right-hand side where we have the dam crest, and the access road actually goes through the spillway. And so during high inflow events, that access is cut off due to the water. And so this would be a rating of 3. So this would be a maintenance action that there needs to be access established so we can get access to the dam even during those high flow events. So some examples of the reservoirs. On the left-hand side, you can see a reservoir that's very well maintained, no floating debris. We have a lot of freeboard available. So this would be our default rating of 4. There's no concern here. On the upper right-hand side, you can see the reservoir here, and here's the crest. We've got less than 2 feet of freeboard, and so this is a high hazard dam, and this would be inadequate freeboard, and so this was a rating of 2, which is a potentially unsafe condition. And then on the lower right-hand side, you can see lots of floating debris in this reservoir. This was given a 4-, a recommendation to have this removed. This could have also been a 3, but in conversation with this dam owner, they were aware of it and were planning to address it soon. So 4-. We'll inspect the spillway, and so we're going to mention what kind of structure the spillway is, whether it was earthen lined open channel or concrete, culvert or rock lined, or trickle tube. We're going to look at the approach channel, if there's any debris in the channel or trees or brush growing in the channel, any erosion that we notice. Looking at the control section, stating what type of control section it is, and whether or not it's unstable. We'll oftentimes give spillway dimensions, so we'll take a measurement while we're on site. We'll also state if there were any flashboards and the condition of those flashboards and whether they were in place or not during the inspection. Also looking at the discharge channel, looking for trees and brush, any kind of head cutting, which is an erosion pattern that will cut its way upstream, eventually reaching the reservoir. We'll look at the stilling basin, if it's functional, if there's any erosion. Not all dams have a stilling basin, but for those that do, we will take a look at that. And then also at your auxiliary spillway, again, which is also your emergency spillway. So taking a look at those conditions. So some examples of spillway. So this is your primary spillway or trickle tube in this case. On the left-hand side, you can see this had a rating of 4, so we've got the trash screen in place. It is clear of debris, so that's good, adequate. On the right-hand side, we've got, you can kind of make it out here, but here's your trash rack that we can see, and it's covered with vegetation and likely soils around it. So inspection rating of 3, which is a maintenance action, and so that material needs to be removed so it doesn't prevent flow into the inlet. And here's like an auxiliary spillway, the emergency spillway, and this is the same spillway in both photos. On the left-hand side, you can see where the discharge channel is clogged with vegetation. You can see a large clump of reeds here and some woody vegetation, really impeding flow through that discharge channel. And on the right-hand side, you can see where they've done the work to remove that vegetation and restore that spillway, and water is now able to flow as it should. And so this would be brought back to an inspection rating of 4, adequate. We'll be looking for any seepage or leakage. We'll state at the top of this section what we've seen. So if there's new seepage or leakage, any piping observed, looking for discolored water if there is seepage noticed or boils down near the toe of your dam. We'll mark the approximate location where the seepage is occurring, and then what condition we're seeing that's an indicator of seepage. So whether that's wet vegetation, spongy soils, standing water, flowing water. If there is flowing water, we will indicate an estimate of what that flow might be. We'll be looking at tow drains. Not all dams have tow drains, but for those that do have them, we'll be looking to see if they are working or if they're damaged or if they're buried and clogged. If they are working, is there any kind of sediment that's coming out of them? So some examples of seepage and leakage. On the upper photo here, you can see this is given an inspection rating of 4-, which is just a recommendation to monitor in this case. But you can see where a lot of the dry grass is looking fairly brown. We have some very clear areas that are a nice green grass growing. So an indicator that we have water near the surface of the embankment in these locations. Lower left-hand side here, it's hard to see what we're looking at. Kind of looks like a muddy mess here, but what we're seeing is seepage due to a blocked tow drain outlet. So this was given an inspection rating of 3, and that maintenance action would be to clear the tow drain outlet so that hopefully we see this seepage reduce and be directed through the tow drain itself. And then on the lower right-hand side, we can see a functional tow drain outlet doing what we would want it to do. So bringing that water from the dam embankment to the discharge channel. We will be looking at the conduit. We'll mark whether it was manually controlled or power controlled. We'll be looking at the inlet. I would say probably 95% of the time that inlet is submerged, so not often do we get a chance to look at the inlet. We're looking at the control and stem to make sure that 1, it's in place, and 2, if it is in place, is it damaged or is it operable? We'll ask you a bit about your valve cycling. When was the last time it was cycled? Were you able to cycle it? We'll look at your principal conduit, looking at the diameter and size and the material and the condition of that material. So looking for corrosion, holes, that sort of thing. Looking at the outlet, if it's free flowing or is it buried or obstructed? Is it overgrown? And we'll also mention if it's pressurized. And then any other outlets. Taking a look at those as well. So some conduit examples. On the left-hand side, you can see a manual valve control. You can see we gave this an inspection rating of 3. So visually, just looking at this would not necessarily be an indicator of 3, but during discussion, it was found that this particular control had not been cycled in over a decade. And so there's some question of whether or not this control is still functional. So a maintenance action is issued to either cycle this valve, or if it's inoperable, to bring it back to operable condition. And on the right-hand side here, you can see a conduit outlet, and we're looking downstream of the discharge channel, which is nice and clear in this scenario. So inspection rating of 4. We'll look at the structure of the dam, and we mark what type of structure it is. So earthen embankment is the most common. We have a few that are rock fill dams. We have a few concrete. And then we have a category for others. So in the state of Oregon, we do have a couple that are actually timber dams. We're looking for deformation on the dam itself, so cracks or landslides, sinkholes, any other indicator of movement of the embankment. We're looking at the crest for any settlement of low spots, any narrowing of the crest, and then any erosion on the dam. While we're on site too, if there's auxiliary dams that retain the reservoir, we'll also look at them as well during the inspection. So some examples of different structures of a dam. On the left-hand side, we see an earthen embankment dam with a nice low grass cover. In the middle, we see a rock fill embankment dam with a concrete cutoff wall that travels longitudinally through the approximately the center of the dam. And on the right-hand side, you can see we're looking at the downstream face of a concrete dam. So during inspections, we'll be looking for longitudinal and transverse cracking on the embankment. Longitudinal cracking is cracking that runs parallel with the length of the dam, whereas transverse cracking is cracking that is perpendicular to the length of the dam. Cracking on the dam can be an indicator of embankment movement, early indication of developing slide or foundation settlement. And generally, small cracks should be monitored for worsening conditions over time. On the left-hand side, you can see, again, that same example of an earthen embankment dam with a low grass cover. This is really nice because you can see all surfaces of the embankment and tell quickly that there are no indications of an issue with the embankment. On the right-hand side, you can see this is the same dam, photos of the same dam. On the left-hand side, you can see a slide on the upstream slope, and that's me standing on the head of this slide for relative size. On the right-hand side, you can see a transverse crack. It's about 6 inches wide, going through the embankment and leaking through the dam. And so this would typically be in a potentially unsafe scenario. This dam in particular was an off-stream reservoir, and so the reservoir had not been used in a long time, but still a potentially unsafe scenario. So looking at animals and vegetation, looking for any indication or evidence of animals, whether that's trails or burrows. If there are burrows, are they deep and are they extensive? Looking at vegetation, ideally there's a low grass cover if there's not a rock cover on the dam. We're going to indicate whether it was high grass or brush, small trees or large trees, whether or not that impaired the inspection in parts of the dam. In the very bottom of this form, you can see where we will indicate if we need to expedite the next inspection. So it might be that, like I mentioned, on significant hazard dams, they're usually inspected every 3 years. But if there is something noticed that need to be addressed earlier than 3 years, we may expedite the inspection for either the following year or within 2 years. We'll also note whether a maintenance action was issued, or if there was a previous maintenance action and this was a subsequent inspection noting that same deficiency. And then also if there's a corrective action needed. Some examples of animal damage on dams. You can see on the left-hand side, this was an example used earlier as well, but we've got some terracing and steepening of the downstream slope due to cattle activity on the dam. You can see where this downstream slope eventually had a slope failure. So it'll be a rating of 2 for that condition. On the right-hand side, you can see right here and a few up here as well, but some nutria burrows that have collapsed on the upstream slope of the dam. So this would be a maintenance action or a rating of 3 for pest control. And you can see on the lower left-hand side, these are taken at the same dam. And so here's the guy that's causing the damage, one of those nutria. Some vegetation examples. So on the left-hand side, here again is that dam with the low grass cover, an ideal condition, rating of 5. In the middle, you can see where we have vegetation that's obscuring visibility on the dam, so impeding a thorough inspection. This would be, again, a rating of 3, so maintenance action needed to remove that vegetation. And then on the right-hand side, you can see where this was given a rating of 2. And here's the crest of the dam, and what you're seeing are large trees growing up near the crest of the dam, which can be a potentially unsafe scenario, having large trees up that close to the crest. Here's an example of the first page of the inspection letter. So on this inspection letter, we provide a summary, and that summary is a reflection of the features that were inspected and the ratings given to each one of those features. And the letter will provide more detail on any maintenance actions that are needed on the dam. So zooming in on that summary, you can see we have each one of the features or categories that were inspected. We have it marked whether it was inspected. So if these are not marked, it means we could not inspect that particular feature for one reason or another. And then the results of that inspection. And so whether it was adequate, so that'd be that rating of 4, or whether there was some maintenance needed. So that's that 4 minus a 3, or possibly going to a 2 or a 1. And then details and recommendations. So each one of these features will be discussed in further detail in the inspection letter, letting you know what we've seen in terms of what maintenance is needed and what the different options might be for doing that maintenance. You can see here where we looked at the reservoir, and we'll always let you know the reservoir level at the time of the inspection, as well as the minimum freeboard that was estimated during the inspection. And so that spells that section of the form out a little bit further in the letter here. And that is what I've got for inspection form and inspection letter. Are there any questions before we go on to the next section? I'm not seeing any questions come through, so it sounds like there may not be any, but I will continue to monitor the chat if I see any come through, and I will answer those accordingly. Thanks, everybody.
Great. Thank you, George. And so the second part of this session is on maintenance and corrective actions, which George talked about briefly, and I will go into more detail on. Let's see. Okay, maintenance and corrective actions. So in this presentation, I'm just going to go over the definitions, provide some examples, and then walk through the process for maintenance and corrective actions. And so maintenance and corrective actions are required actions. They're required for high and significant hazard dams. We don't assign these to low hazard dams. Only because we don't have the authority to require actions for low hazard dams. However, it doesn't mean that the safety aspect and the safety actions related to these aren't important for low hazard dams, or not applicable. And so just be aware that just because these are for high and significant, the content of this is still applicable to low hazard dams. And so these are required actions, as I mentioned, and they are required for certain safety issues. And so in order to understand maintenance and corrective actions, 2 terms need to be defined: potentially unsafe and unsafe. The Oregon Revised Statute number is listed for both of those, and for potentially unsafe, it just means that the dam is not likely to withstand an extreme event like a flood or an earthquake, or there is a high risk of internal erosion. For unsafe, it's likely that the dam will not retain water as it was designed or operated, and that inability could lead to a dam failure. And so in order to understand the difference between the maintenance and the corrective actions, it's in how they relate to potentially unsafe and unsafe. And so for a maintenance action, it's an action needed for a safety issue that may cause an unsafe or potentially unsafe condition in the future, in the near future. For a corrective action, it's an action that's needed to address a safety issue for a dam that is unsafe or potentially unsafe now. So maintenance action could be unsafe, unsafe in the future. Corrective action is unsafe, potentially unsafe now. And so the image on the left here is an example of a maintenance action. The spillway is blocked by debris, and so that would get assigned a rating of 3, as George mentioned, and it needs to be cleared. And so the image on the right here shows this is an emergency spillway. The original spillway, how it was designed and how it was at one time, is identified by this line here. So this was just an open channel. And the owner had filled it in with these culverts and this fill material here. And so now the spillway is blocked, and so, or at least partially blocked from what it was approved and designed to be. And so that results in an unsafe condition, which means that it's a corrective action. Here's another example. The image on the left here, this is the dam. There's quite a bit of brush and some smaller trees here. And so this is a maintenance action because it's not unsafe now, but if it's left unaddressed, this will become unsafe. And so that's a maintenance action. The image on the right here shows several large trees growing near the crest of the dam, and we've heard already, why that's a safety issue, a serious safety issue. And so that means this is unsafe now, and so it needs a corrective action. And so this slide just provides the definition of a maintenance action that's in statute. The rule related to maintenance action is also listed here, this OAR. And so the rule provides several examples of what maintenance of some maintenance actions. And some of those are listed here. I'm not going to read through this, but just know that there's some on the slide. There's even more in the rules. But I would like to point out that there is also a catch-all in the rule, right, that allows us to assign a maintenance action to basically any condition that might affect the safety of a dam. So just because it's not listed in rule doesn't mean that it can't be a maintenance action. And so here's another example of just a maintenance action specifically. These are two different dams. They both have wave erosion on the upstream side. And so when the reservoir level high, the waves hit against the crest and they begin to remove material. And so in this case, the crest is still pretty wide, so it's not unsafe yet, but if it was left unaddressed, more and more material would continue to be removed, and eventually it would get to the point where it is unsafe. And so for now, since it's not unsafe, it's a maintenance action, and the dam owner just needs to add some riprap, large rock, and some fill material to this side to stop the erosion. And so the process for maintenance actions are that, as George mentioned, we would identify the safety issue during the inspection. And if it meets the definition for a maintenance action, we assign the maintenance action in the inspection letter. And at that point, we would work with the dam owner cooperatively to set a plan and a schedule for the maintenance action to be completed. And once it's completed, we would verify that, and typically that would be during the next regular inspection, but could be during an expedited inspection. And if the work is completed, the maintenance action is removed. If it's not completed and the dam owner is unwilling to address the required maintenance action, civil penalties may be assessed. So corrective action. As I mentioned, these apply when the dam is unsafe or potentially unsafe now. So when an issue is identified through inspection or analysis, and it's declared unsafe or potentially unsafe, that's when a corrective action applies. And so for both of these, the Oregon Administrative Rule is listed that provides examples. Again, and I'm not going to read through these, but there are some examples here. There are even more examples of what a potentially unsafe and unsafe condition are in the rules. And similarly to maintenance action, there is a catch-all for both of these. And so any other condition that meets the definition of potentially unsafe or unsafe can be assigned a corrective action. And so here's another example, and you've seen similar examples to this. This is trees near the crest of the dam. And so here's the top of the dam, the crest of the dam. Here's the reservoir over here, and you can see there's trees lining both sides. And on the downstream side, there's some pretty large trees. And so this is unsafe now, so it gets assigned a corrective action. And so our process for corrective actions are that, again, during an inspection, we identify the safety issue, or in this case, which is different from maintenance actions, it can also be determined from an analysis. And so once we identify that a corrective, that an unsafe, potentially unsafe condition exists and that a corrective action is needed, the dam is declared unsafe or potentially unsafe, and a corrective action is assigned in a document called a notification of unsafe, potentially unsafe dam. And so this document contains a lot of information, and part of that is the rights of the dam owner related to this. And so if the owner agrees to address the corrective action, the owner will submit a plan and time frame to the department for completing the corrective action. And OWRD will review this, and if we agree on the plan and time frame, we will enter into a consent order with the dam owner. And so a consent order is just a document that the owner signs that says, yes, I am going to do this work. And so once the work is complete, we will verify, and the corrective action goes away. And so if the owner does not agree to address the corrective action, there are a couple paths forward. The owner has the opportunity to provide evidence as to the potentially unsafe or unsafe condition that the department has defined for the dam is incorrect. And so that evidence is typically in the form of some type of analysis from an engineer. And so at that point, the dam owner submits that evidence, the department will review it, and we would either agree with it or disagree. If we agree, the corrective action goes away. If we disagree, then the owner has another option. There is an option for a hearing in front of an administrative law judge. The judge would hear the owner's side and the department side and then make a ruling. And depending on what that ruling is, there may be work required by the dam owner. And so with that, I'll open it up to any questions. So let's see. The corrective action process slides discuss potential vulnerabilities in dam safety risks for existing dams. Is OWRD looking to federal agency guidance for risk analysis methods to inform such decisions? If so, where do ORS or OWRD statutes describe when and how that is implemented? Same question for proposed modifications to existing dams. Let me see. Yeah, so I think that the short answer is that we have our own internal process. We don't really look towards what the feds do as far as risk analysis. We have our own way of judging that, but the corrective action, the vulnerabilities aren't necessarily based on a risk analysis, right? Like a vulnerability could just be identified from a hydrologic analysis, like a spillway capacity analysis, or a seismic deformation analysis. So short answer, no, we don't necessarily look towards the feds. We're going to get into modifications here shortly. Let's see so where do ORS or OWRD statutes describe? Let's get through the modification section. If you still have a question, we can discuss that. That's actually the next session that we'll have. So. Okay, I'm not seeing any other questions. So the next session is on modification, construction, and removal, and I will turn it over to to Arden.
Yeah. Hi again, everybody. Go ahead and share. Okay. Hopefully everybody's seeing that all right. Okay. So I guess I'll go back to the main slide. I'm generally going to be talking about new construction and increasing height on dams. Quick clarifying point, this is not the presentation on modifications to existing dams, which has a different set of rules. George will be covering that after I'm finished with this presentation. So just general overview, some general notes to keep in mind when constructing a new dam or increasing the height. The design process overview, what that looks like for owners, operators, engineers, and dam safety. Preliminary plans and specifications, inundation analyses that are needed, final design report elements, and more detail about the reports themselves. What to look for in design drawings, construction specifications and administration, the construction process overview, a quick touch on operation and maintenance plans again, and then just some notes on written approval by the state engineer, which in this case is Tony. So starting out, designs need to be submitted and approved by OWRD prior to any construction work beginning. Owners are going to need to work with an engineer, depending on the hazard rating or the scope of work being done. This could also be a team of engineers. This might include geotechnical engineers, structural, hydraulic or hydrologic, just to name a couple that you might see involved. Engineers need to be meeting, or the engineering team needs to be meeting with OWRD really early on in the process. There's a number of rules related to site-specific conditions that may not always be apparent without meeting with us and getting some background information on the geology or the location of the proposed dam. So, overview of the design process. First and foremost is the preliminary plans and specifications need to be submitted. This was not previously required before our new rules and regulations went into effect, so it's an important step that needs to be included now. After that, the inundation analysis needs to be submitted for review by us and approval by us. That'll determine the hazard rating and the design criteria that need to be met, and I'll touch base on that in a few slides. OWRD is going to review that inundation analysis, and we're going to confirm the hazard rating. The engineer on staff can recommend what they think the hazard rating would be, and we'll either confirm that yes, that's what we agree on, or no, we need to see changes. Then the team will meet with OWRD prior to starting the design to get some of those background information if needed and make sure everybody's on the same page with the design. At that point, the design process can start. Any additional meetings that might be needed to go over questions or concerns that might have come up, and then the final design will be submitted for review by us. And I'm going to touch on a few of these in a little bit more detail as we move through. So the first one is preliminary plans specifications. A lot of these rules are pretty detailed and there's a lot of language in them. I'm just going to briefly touch on these, but they are referenced in all of our OAR rules. If there's a water right application that was needed with the dam, preliminary plans and specs must be submitted at the same time as the water right application. Very briefly, the specifications will include a contour map showing some of the key elements, the location of the dam, a cross-section showing the maximum height, proposed storage in a storage area curve, and a description of the geology at the site. And then they need to be submitted by an engineer or certified engineering geologist. So an example, the details of this don't matter, but it's the general overview of what a couple of these contour and site maps might look like. Up in the top corner here, there is, it's a cool old monument that somebody took a marker and, scratched off like you would a drawing that you'd like, showing the location. And those monument markers typically are set in concrete or foundation, so you can reference them back to back. So touching on the dam breach inundation analysis, this needs to be completed before any other part of the design because it's going to determine what specifications you need to follow for the dam hazard rating. So we'll need to review it, we need to approve the hazard rating, and then confirm that the work can move forward with that hazard. Failure to do this can result in wasting money and delays for the owner and the owner's team, which nobody wants in this case. The models themselves, significant and high hazard, require an accepted hydrologically consistent computational model. Keith touched on those at the very beginning of the process, and then low hazard simplified models are used. And that picture at the bottom is just typically what an inundation map might look like. You can see the blue shows depths greater than 4 feet, and then houses that are outlined in red, which in this case would indicate a high hazard dam because of those depths at the structures. So this is now touching on the final design documents that'll need to be submitted. These are going to include final design reports, which I'll go into exactly what those reports are on the next slide. We'll need final design drawings, a plan for construction administration, an operations and maintenance plan if it's required, and then an emergency action plan for high hazard dams. And again, highly recommend meeting with us early in this process so that everything is very straightforward and streamlined for both sides. So going into those final design reports, there's going to be 7 different reports. All of these have very detailed, very specific rules, which are referenced at the bottom. I'm not going to be touching on all of those. It would be too much for everybody and just not a fun time. But I am going to be touching base on what we typically see people miss or some items that are especially important to note. But of these reports, the first one that's going to be involved is a site suitability evaluation. There's going to be a hydrology and inflow design flood report, the dam structure design for either concrete or earth embankments, spillway design, design for the conduits, any monitoring and instrumentation that might be on the dam, and then the dam breach inundation analysis, which we just touched on. So the first one we'll look at is site suitability and geotech. So a full site analysis is going to be needed for the design process. This is going to be a subsurface investigation. This is going to look at earth materials. This will include borings, which that test pit log on the right-hand side shows the distribution of materials in the boring pit. Identification of any springs or groundwater that could potentially be a problem. And then any potential for landslides. These, when Keith talked about his soil section, a number of these were touched on. And the other thing that needs to be considered is earthquake considerations. Seismic characterization is required for highs, but it might also be relevant for significance if you're in an area of pretty high earthquake potential. So the next part we'll look at is the hydrology and inflow design. So the inflow design flood is going to be based on the hazard rating. This, for highs, is the probable maximum flood or risk-based analysis. So the probable maximum flood is the largest flood that could occur at a specific location. This is determined by atmospheric conditions, soil moisture, snowpack, and several other criteria. And then for significant hazards, it's the 0.2% annual exceedance probability, which that's just the likelihood of a specific flow being equaled or exceeded in a given year as a percentage. For lows, that is the 1%. And then there is some work being done currently with some consulting groups to help inform these values, and hopefully within the next couple years that'll be available for folks to use. So these inflow design floods are important because they influence the design of the spillway on the dam. Spillways are required for all high hazard dams and dams that are on stream channels. So the capacity is based on this inflow design flood that I mentioned. So there needs to be 1 foot of freeboard for high hazard dams and 2 feet of freeboard for significant and lows. But most importantly, that's during that high flood condition. That's not just general operational freeboard. So when that potentially maximum flow is coming through the spillway, going through the reservoir, they'll have 1 foot of freeboard or 2 feet for significant or lows. Needs to have a stable control section, and the spillway channel needs to include earthquake considerations for high hazard dams. Any dams that are off channel, for low and significant hazard dams, they don't require a spillway if there's a redundant mechanism to prevent the water from going over the top of the dam. So the next part to consider is penetrating conduits. So generally, they just need the ability to lower the reservoir. There are 2 specific time frames, depending on the hazard rating, that need to be considered. So for high hazard dams, they need to be able to release the top 5 feet of water in 5 days. For significant and lows, it's the top 5 feet in 10 days. And so that's part of that initial hazard rating analysis needs to be done so that the conduit can be appropriately sized. And again, there's significantly more rules and regulations that are involved with all of these. They're all referenced in the TOPS, and the Oregon Administrative Rule can be read through thoroughly. Quick touch on instrumentation and monitoring. We get designs in that don't necessarily realize that a staff gauge is a requirement. These need to be marked in feet and tenths of feet and extended within 1 foot of the crest. This example on the right-hand side, although it's a little bit of an angle, you can see that it's easy to read while you're standing on the crest. Clearly shows the depth of the water and is easily accessible and maintained. Couple just general notes. For geosynthetics, they cannot be used by themselves in a design. There has to be a redundant feature to help with that. And then any exceptions to design standards, they have to be obtained with written approval from the state engineer when the engineer of record requests it. So yeah. Quick touch on design drawings. So again, there's several more requirements than what I've listed, but these are a couple that we tend to see issues with. We need an official dam name that's not already in use, which might seem logical, but you know, there's several dams on the same stream or river. A lot of people want to name them the same thing, so we need to plan for that. We need an area capacity curve showing the total capacity to the crest and the spillway invert. And I have a couple examples of that, which we'll go through. And then a cross-section of the dam, including the maximum section with the official height. An example below is just some of the elements that you might see on a set of design drawings. So this maximum height that I just mentioned, Keith had another picture of it earlier on today, but it needs to make sure to call out from the crest to the low point on the dam the average natural ground height, and just needs to be clearly identified on the drawings. And then for the capacity curves, it needs to extend to the top of dam elevation. So in this case, the crest elevation based on these drawings is 106, but you can see that the capacity curve only goes to 100. So we would need the curve to extend up to where that red dotted line is. And this is a requirement for the design as well, which some folks can miss. The other note is that the spillway invert, which in this case is at 100 feet, is not specifically called out on the curve, and that would need to be identified as well. Quick note about construction specifications. This needs to be a separate bound document and not text within other reports or drawings. It needs to be easy to find for us and clearly labeled. We've had sometimes with all of the specifications included in the drawings, and then it's difficult and time consuming for everybody that way. So this will just be a separate document by itself. Related is construction administration. So engineer of record or a representative needs to be on site as often as needed to approve excavations, make sure the materials are what they said they were supposed to be. General project administration, they need to make sure it's consistent with the approved design and that the foundation design assumptions and the cutoff trench were as expected. They also need to maintain a record of construction. So this is an example of a set of photos that were logged by the engineer of record showing various construction elements as they were on site. A couple of trenches being dug, the workers, the soil characteristics, things like that. So moving on to the actual construction process. So once Oregon, the OWRD reviews the final design, which could take several iterations depending on if we have feedback or not, the review is completed and then the design's ready to approve. At this point, fees associated with the review will be assessed, and it's based on the time it takes for a review, which is again why the clearer and more straightforward construction administration, all of the bound documents are, the better for all parties. Once Oregon approves, the construction can begin. So again, the engineer of record or rep needs to be on site. OWRD may construct or may conduct construction inspections as well. Typically, we like to see the cutoff trench, for example, if we're able to see the conduit being installed, things like that. We prefer to be on site for that. Construction is completed, and then the project completion report is submitted. We'll accept it, and then the dam can now store water. So important note, if for whatever reason the dam is storing water prior or if there was an increase storing additional water prior to our approval, civil penalties can be assessed at this point. So touching base again on operations and maintenance plans, these will be applicable to significant or high hazard dams for the most part. Low hazard dams with gates, flashboards, or valves would benefit from them as well. Operational procedures need to be included, which I've touched on in the previous presentation. Inspection frequency, any maintenance that might be needed, safety for water release plans, and then review regular evaluations for any repair or maintenance that might be needed. And then during our inspections, we may review this plan just to make sure it's consistent with what we want to see on the dam. And then the last slide I have is just a quick note on written approval. So necessary reports and plans, they all need to be approved and signed off on by the state engineer. We need to verify all of this before any construction begins. The approval is valid for 5 years, which may seem like a long time, but if you get behind in construction or there's any delays, we would have to then reapprove the design after that 5-year period. As it's noted, the extensions for this can be requested. And then again, mentioning that water storage, no new or height modified dams can store water until a project completion report is submitted and accepted. And then final acceptance, the department will notify the engineer of record and the owner that we've approved the design and the acceptance report. So I think that's what I have for everybody. Yep. So I'll close out of here, see if there are questions I can answer. Let's see. Nothing yet, but I'll wait for a few minutes to see if anybody has questions.
Yeah, thank you, Arden. Yeah, and we still have plenty of time, so let's just give it a minute or two and see if we get anything.
Sure.
Okay. I'm not seeing anything, so if they come up, Arden, just please answer them in the chat. And so the second part of this is on modification and removal, and so for that, I will turn it over to George.
Thank you, Tony. All right, so looking at modifications and removal of dams. So what's a modification? We would define modification of a dam as a change to a dam that has a potential impact on the safe functioning of the dam, and are to an extent that the modified structure no longer conforms to the original design. Modifications do not include increasing dam height, performing maintenance actions, or removal of the dam, and we'll go into removal a little bit later. Increasing of dam height, that falls under what Arden just presented on, so new construction or construction of a dam. So for dam modifications, a modification does require a design plan, and design plans for modifications of a dam require review and approval by the department before construction begins. And that's an important note because modifications done without department approval may be assessed civil penalties. Design plans must be developed by an engineer licensed in the state of Oregon and qualified to do the work. And some common modification examples, so changes to the spillway, placing, replacing, or relining any conduit within the dam, removal or alteration of the conduit control structure, installation of a new valve on the downstream side of the low-level conduit, and correction of damage where the damage has impacted the safe functioning of the dam. And so an example of this might be where you've had an overtopping event, has not resulted in a full dam failure, but has resulted in substantial damage to the downstream slope. And so correction of that damage would be a modification, and we would want to see plans for that repair. So it's always important to contact the department early if modifications to the dam or spillway are being considered, and that will allow the state engineer to be able to determine the design and submittal requirements needed for review for that modification. It will also allow us to potentially get it in our queue so that our review times can be as efficient as possible. Some examples of modifications. So on the left-hand side, you can see where a low-level intake pipe is being removed and replaced with a new one. It's hard to make out here in the dirt, but here's your intake structure where the slide gate would be located. This is where the original low-level pipe would have been located and connects back into this junction box down here. And this vertical pipe that we're seeing is that trickle tube spillway, or that primary spillway within the reservoir. This was an approved modification on this dam. And then on the right-hand side, we're seeing a modified emergency spillway. So you can see the red outline where the original open channel spillway was designed. And this dam owner has placed 3 large culverts within the spillway and then backfilled between those culverts with rock and dirt to create a roadway over the top of the spillway. This was not an approved modification, so that is something that we are working with that dam owner to resolve. A couple more examples, and Tony went into much more detail on this one than what I'm going to do in this presentation, but here is a rehabilitation of a low-level conduit, where we have the original low-level pipe, the larger pipe here, and we're having the smaller diameter pipe slip-lined into or inserted into the larger original pipe. And then on the right-hand side, we have an example of adding lifts of material to the crest. So generally, if the lift is 8 inches or less, we would just consider that maintenance and not necessarily a modification. If you're going over 8 inches, that may fall into the category of a modification. So an important note would be is if you're going to add material to the dam, just reach out to the dam safety office so that we can take a look at that, and we will help determine whether we're going to look at that as a modification or just maintenance and guide that accordingly. And that's what I've got for modifications. Any questions on modifications before I move into removals? I don't see anything coming up, so I'm going to move into removals. So dam removal, we would define that as demolishing all or a portion of the dam structure, permanently preventing storage of water. Removal of high or significant hazard dams require notification to the department and a removal plan. Those removal plans must be approved by the department before demolition begins. And just like with modifications, a removal of a high or significant hazard dam without approval may result in civil penalties. You'll notice that low hazard dams are not mentioned here, but we do ask that if a low hazard dam is being removed, that you communicate with dam safety so that we can come out and verify that the dam has been removed. And then after that verification, we can remove that dam from our oversight. And so once that dam is removed from our oversight, you'll no longer receive an invoice for the annual dam safety fee for that dam, and we will no longer schedule inspections for that dam. So dam removal plan, what does that need to include? So we're looking for descriptions and assumptions for the removal of the dam, a description of the means for removal, a method of draining the reservoir in a controlled manner, a schedule of major events and corresponding timeframes for that removal, a plan for the disposal and stabilization of dam materials, and a drawing showing the planned removal location, breach dimensions, and lowest elevation of the breach. And so generally, we're looking at these plans from a safety perspective. And so where dam removal may be just a notch of the dam and not a complete demolition of the entire dam, we would look at the remaining soils or slopes to ensure that there's not a condition where we may have some slope instability or a slide condition where that soil could slide back down into that stream bed, creating a dam situation again, or a condition where maybe there's unstable soils that could easily erode downstream. So a couple examples. This is a full dam removal, and so we're looking at the same dam in each one of these photographs. On the left-hand side, we're standing in the empty reservoir, looking at the upstream face of the dam. You can kind of make out here the small concrete structure housing the controls for this dam, and then the stem going down to the slide gate down here. And then on the right-hand side, you can see where this dam has been fully breached down to stream bed elevation. And so this would be a full removal. Another example of removal is where we have a dam that has been removed such that it's no longer statutory. So if you recall from earlier, a statutory dam means a dam that is state regulated, meaning both criteria below. So a height of 10 feet or more and a reservoir storage of 9.2 acre feet or more. Non-statutory means the dam does not meet at least one of those criterion and is therefore not state regulated. So in this example, we can see on the left-hand side, this is the same dam in both photos. On the left-hand side, we see the original embankment. And then on the right-hand side, what we're looking at here is a notch to the dam. And so what this dam owner has decided to do is to hire an engineer to take a look at the reservoir and do an analysis to determine how large a notch is needed on this dam such that the resulting reservoir capacity is no longer statutory, or the reservoir can no longer hold 9.2 acre feet of water or more. And so now that this notch has been verified to have been constructed, the reservoir can no longer hold 9.2 acre feet. We would consider this non-statutory, and so it is removed from our oversight. And that is what I have for removals. Any questions on either modifications or removals?
Thanks, George. I was actually answering some questions as they came up in the chat. And we'll just continue to monitor the chat, and we'll move on to the next session. And so the next session is on permitting for dam safety work. Before we get into the session, I do want to point out that dam safety, OWRD dam safety, does not have permits for dam related work. We just review and approve the design for new dams and modifications to existing dams. However, there are other agencies, both state and federal, that do have permitting requirements, and it's the dam owner's responsibility to ensure that the all permitting requirements are met with those state and federal agencies. And so we didn't have time today to have all of the state and federal agencies present on what their requirements are, and I hope to do a future workshop that covers that in more detail. But today we have Charles from DSL, who will present in a minute. But we also, I believe, have Haley. Let me check. Is she on? Yes, Haley Teach from DEQ to answer questions after Charles presents. So with that, Charles, I will turn it over to you.
Thank you, and thanks for having me today. So I'm Charles Redon. I work with the Department of State Lands, and that sounds like we manage state-owned lands, which is part of what we do. But the section I work for is works under what's called removal fill law. And so I just hope to give you a feel today for kind of what we do, when you might need a permit from us, what some of the exemptions are, and what are some tools and places where you can connect to get more information, find out who to talk to, and whether or not you need a permit for your project. And so I'm going to screen share here, and we should get started. All right. Can one or two of you give me a yes in the chat if you can see the screen that says DSL permitting? All right, thank you. So as I said, the agency, other parts of the agency do manage some state-owned waterways as well as uplands. But what we're talking about here is what's called removal and fill. And so I just want to give you a feel for what that is, and then we'll make lots of time at the end for questions. So we regulate removal and fill, and the way I like to explain this to people is rather than regulating the water or the water quality or other aspects of it, what we are is more like a building permit, so, or a grading permit. So if you want to do work where you're going to be moving earth, putting something in the river, taking it out, you might be doing removal or fill. And when it comes to putting things into the river, it's almost any material that's solid. So if you were putting in rock, if you're putting in wood chips, if you're putting in leaves, if you're putting in concrete, you're probably doing fill and you might need a permit from us. We'll talk about exemptions. And then when it comes to removal, the definition actually doesn't count most organic material, so natural things like leaf litter, wood, etc., for removal. But it does count anything inorganic, so soil, rock, concrete, etc., being either removed from a waterway or a wetland, or being altered within the waterway. It would fall under that same category. So I want to give you a little more of a feel for what do these things look like where you might need to come talk to us for a permit or to get an exemption. And so when it comes to waterways, we regulate intermittent, meaning flowing seasonally, and we regulate perennial, meaning flowing year round, but we don't regulate ephemeral. So ephemeral means maybe there's a grassy swale, it flows when it's been raining hard for 3 days and maybe for a half a day or a day after, but it's not actually forming a channel. Those are the areas we won't regulate. But if it's flowing seasonally for a few months out of most years, it's starting to form some channels, maybe providing some seasonal habitat for fish or insects. That's something we might regulate, even if it's dry at the time you do the project. And then, of course, rivers that are flowing all year round. Where do we regulate within those? Well, we regulate to what's called the ordinary high water. And so where you are in summer might be standing on a dry bank, you might still be within the river as far as the purposes of removal fill law. So ordinary high water is defined as the highest point in an ordinary year. So this is much, much less than, say, a 100-year floodplain that a lot of us are. That's not an ordinary year, right? That's a 1% chance in any year, or 1 out of 100. And we're regulating something more like, if you want to think of it in those terms, the 2-year floodplain. So as high as the water gets for at least a day, at least 1 out of 2 years. That's the area that is within our jurisdiction, and you may or may not need a permit depending on your activities. When we're in a reservoir, so on the upstream side of your dam, there's a similar concept, but it's called something different. It's normal operating pool. And that's the area that is the highest point of normal operations, not flood or emergency overcapacity flows, but up to the highest point in normal operation. Within wetlands, and I'll talk about that in a minute. Many of your projects won't have wetlands, but sometimes they're adjacent to a stream or in an area where you're putting in an access road or some feature like that, and you may need to have that as part of your permit. This is just a computer-generated image, but to talk a little about that concept. So I can see here green leaves on the trees. So that tells me I'm, spring or summer, right? So I'm not probably, for most parts of the state, at the highest flow of the year. So this water level right now is going to be below ordinary high. Obviously, I'm going to regulate anything that's wet, but we might also be regulating, and this would be determined on the ground based on the actual features of the thing. But this grassy area here, this might be what a common floodplain bench would look like. And so up to this level might actually be the boundary of the river for the purposes of removal fill law. And in some cases, you have areas that these might be trees that are staying 3 feet up the trunk because every winter for weeks or months at a time, they're underwater. Well, that's actually ordinary high water. And so for the purposes, again, just of removal fill law, removal or fill of material within those boundaries is going to be it. So it's determined on case by case. In some streams, it's very clear. It's top of bank. The stream never comes out of those banks. That's ordinary high. But in some flat areas or areas that are subject to huge variations, it might be much, much wider than you would see at a normal time of year. When it comes to wetlands, some of them kind of look like what a lot of us might picture, cattails and ducks or marshy look, but many wetlands in Oregon are seasonally dry. And there's a definition for that, a technical definition that has to do with wetland soils, wetland hydrology, meaning water levels, and wetland plants. If you're not sure whether there's wetlands in your area that you're planning to do a project, there's two ways you can go about it at the state level. One is you can come to us and ask for what's called a wetland determination. Those are currently free. And they're basically, you're telling us where you're going to do it, how to get a hold of you, and giving us a quick sketch. And we'll have our wetland specialist look at that area and get back to you saying, hey, nothing there to worry about, or it looks like there's a regulated wetland in this area of the property. You need to take some further steps. And so that's a good way to get that kind of initial look in your planning phases. Or if you're pretty sure you have one, or you've been told you do have one, then we have what's called a wetland delineation. And this is actually an on-the-ground determination, looking at those indicators to say this is wetland, this is not, and providing you with a specific boundary that's going to be good for 5 years. And that's what you would, the level you would go to in a case where a permit was needed and there were wetlands on site, and that would give you the boundaries to support your permit application. And those can be used for other local approvals as well. So that wetland concurrence gives you an official map, good for most types of regulations in Oregon, including state and federal, and that will allow you to go forward. So how does all this apply? So remember, we regulate removal of fill, kind of like a grading permit or a building permit, but only within wetlands and within waterways to ordinary high water. So there's a bunch of options here. I kind of listed them least to most, and the two I've highlighted here are the ones that I would imagine most of your projects are going to fall into. But at the end, we'll have some question and answer time. And if you have something you want to ask me about specifically, I'd be happy to go into those a little more detail. There are some specific exemptions under state law. Some of those require notice and some of those don't. Many of the exemptions, example, maintenance of a water control structure, they have certain thresholds on them. They don't require a notice to us. If you're within those rules, you can go ahead and do your project without needing to talk to us. However, as many of you know, if you've got a nosy neighbor, if you're by a busy road, if you just want some legal certainty before you start a project, that, hey, some guy I heard on a conference one day told me it sounded like it was probably exempt and I don't want to do a project and get into trouble. We offer what's called a no state permit determination. So that's where you can apply to us with enough of a description of the location and details of your project. And within 30 days, we'll send back a letter that says, we agree. If you do what you just described, you're exempt from our permitting requirements. And that's not all state permitting requirements, although we call it that. It's just the Department of State Lands Removal Fill Law. That will also be reviewed by our ownership folks that I referenced earlier. Many of your projects will probably not be on state-owned submersible lands, but some of them might be. That review will be included if you submit that form to us. So that's another advantage, is you get the feedback if you do need some kind of access agreement or lease with us. For the state ownership side, we'll also take care of getting that to you. And then there's a few options in the middle, most of which probably won't apply to your projects, but they might. And they're exemptions that require a notice. And we call those voluntary habitat exemption notifications and general authorizations. And those are just specific permits or exemptions with specific sideboards. And we require the notice so that we can confirm to you, yep, you're meeting all the exemptions, go ahead. And then where most of your projects will fall, if they're larger, they don't meet that maintenance exemption, is what we call an individual permit. And this is allowed to, this isn't designed to cover almost any project you can imagine. Everything from a parking lot to a bridge crossing to major dam retrofits to realigning streams to just about anything. And so those individual permits do require some more analysis, right? They require a lot more information and a lot more time. So talk a little bit more about that. If you think you're exempt, but you want that notice from us, even if it's not required, and you want to apply for that no state permit, it's about 30 days to get that return. It's currently free. In the future, the legislature's asked us to recover more of our costs. So there may be a fee with that, but for now, until at least September, those determinations are free. And like I said, this is a good way to get that kind of written certainty. So it doesn't matter who you talk to on the phone, or if I'm doing something different next week, you don't have to worry that I'm not there to say, oh yeah, I told them it was fine. You've got it in writing. So that's what those no state permits are. I would still allow more than 30 days before you plan to get in the water, so to speak, or get within the river to do the project. Just because sometimes those applications aren't complete. We need a bit more information or a clarification on something. We need to figure out exactly where that high water line is relevant to your project before we can say, yep, it meets the exemption. And if you need to go the individual permit route, statutory review timelines say 120 days from receiving a complete application. However, there's a lot of information needed in those detailed applications. And so sometimes they're not complete the first time. And if we have to send it back to ask for more information, that's going to reset the clock. So how much more time should you allow? My advice is try to plan those bigger projects that are going to require that individual permit a year ahead of when you want to be in the water. At least 6 months, but a year. Now, that sounds like a long time, and it is. However, it's for a number of reasons. For about 15 years, I've been doing this across the state, both the permitting and the enforcement side of this removal fill law. And in my experience, number one, a lot of times there's just some back and forth to get everything complete and clarified so that we can make all the determinations we need under the law to say, here's your permit, and make sure that it's solid. So even if somebody else contests that permit, we'll be there to defend you because we've already made all those determinations. That's one reason. Another is sometimes your schedule changes, right? You need to do something else. It's going to be a while before you get an approval from somebody else so that you can provide to us to complete your process. And so, like I say, I recommend at least 6 months to a year, but only for these larger projects. All right. And again, but whether you apply for a no state permit or you apply for a permit and it turns out your project qualifies for something less onerous, we're going to let you know that. Or if it needs to go to a different path for another permit, we're going to let you know that. We want to help you get the quickest, most relevant permit or exemption for your project. So sometimes we have emergencies, right? There is no year to wait because it's about to blow, something's going to be flooding the road, the intake line's going to break, whatever that case. If that happens, we can do what I'm calling issue now, pay later. So the only permit you can get where you pay after the fact is an emergency permit, right? And this is because sometimes something needs to happen right now. And these can be kind of one-page application forms that we get, you send into us late on a Sunday night, and by Monday morning, we're back to you. They can even be verbal authorizations. It's dependent on the actual situation. So what is an emergency? I procrastinated and now I want to get this fast. I don't want to wait for my permit to come through. That's not an emergency. But under state law, circumstances that poses an immediate threat to public health and safety or substantial property. So things I kind of threw out there. If something is going to be dangerous, if something is going to wipe out an adjacent farm field or a barn or a road or the dam itself, those are all clearly emergencies. And we will get you an emergency permit as fast as we can. And we'll come back after the emergency passes to make sure everything comes up to state standards. So that option is available. You can do that by calling any of the people at DSL, by sending us an email, by reaching out to Oregon Emergency Management if it's outside of business hours. So I want to make folks aware on that. So how do you contact somebody at DSL? How do you know if you are needing to get a hold of somebody to help clarify? What do I need? Am I exempt? Am I not? How do I contact somebody about emergency? We have an interactive map, and because I knew this would be hard to read, I put the link down here at the bottom, and we'll make sure that everybody gets a copy of the materials. I was later, so I don't think Water Resource folks have had a chance to get those to you yet, but we'll make sure you do. And this link right here, in fact, I can show you. Will let me. Well, it doesn't want to do it from within PowerPoint, but this link that will be in your materials takes you to an interactive map. And the reason I like this is you can just go to the county where your project is located. So not where you may happen to be at the time, but where the project is. You click on that county and it will give you a little pop-up window here. If you need help with removal fill permitting or exemptions, it'll list the removal fill person. If you need help with a wetland delineation to map out the boundaries and planning for a project, it'll list who the wetland delineation contact is for that county. All right. And then here's some more tools. Not everybody wants to just call somebody and ask. They want to kind of do their own research. They want to figure things out on their own, and that's absolutely okay. And again, these links will be in the materials that I'll make sure get to each of you. But I want to cover a couple of things here just to show you what's available. The first is the forms page. Of course, we have forms for our different types of permits and applications, and that will take you straight to that page rather than having to search through our website. There's a consultants list. Now, this is not required to be used, but if you're going that individual permit route, you might need some technical help for some of the assessments and delineations and things that are required for that. There's a Society of Wetland Scientists that maintains a consultant list for the Pacific Northwest. That's what that link is. So not required, but we recommend if you have more technical work to do in preparation for your permit application, that you give a call, talk to one or more of those consultants, and they're the folks that do that kind of work all the time. ESH map. Now, some streams in Oregon are designated essential submoded habitat and others are not. The primary effect, and the reason I want you to be aware of that, is if your stream is, it changes one of the thresholds for when a permit's required and when it's not. So some of you may have heard, I need a DSL permit if I do more than 50 cubic yards. And for many streams and wetlands, that's true. But if you're in an essential submoded habitat area, the threshold drops from 50 to 0. So in other words, any amount of removal fill that's not specifically meeting an exemption requires a permit. All right. And then the removal fill guide is like what I liken it to an encyclopedia. This is just a big reference document that explains removal, explains fill, explains how we calculate it, gives you sample pictures, terms, defines different types of permits, has links to forms. And so you can go to that removal fill guide, you can hit Control F on your computer and you can put in the word, what do I want? Dam exemption. It'll find all the cases of that in this larger encyclopedia. So that's an easy way if you want to do some research on your own. And so now I'd like to hear your questions, and let me see if there are any in the chat. I'm trying to figure out where we picked up here. Looks like the first one that might be directed my way is, do you need a permit to construct or replace a dock on a dam? So the answer to that is probably. And the reason I say that is usually a dock is either floating in the water or supported on pilings in the water. And so remember, our regulatory line is ordinary high water below the dam, right? Or similarly, normal operating pool above the dam. So if your dock is intended to have access to the water for a boat, for maintenance access, whatever, it's got to be in the water for a majority of the year. Therefore, it has to be below ordinary high water, right? The highest point in a normal year. If you put your dock above that, you're going to have a long jump to get in your boat. So yes, most of the time, but remember also there's different thresholds for different areas. So if it's not an ESH stream, even though you're in our jurisdictional area, the area we regulate, you may not need a dam, or excuse me, you may not need a permit from us to put that dock on your dam or to maintain it because you're below the 50 cubic yard threshold. But we're in an ESH stream or a state scenic waterway, which would be rare, but you may have some structures in state scenic waterways. Then that threshold might drop to 0 and you might need the permit. So that's why I give this interactive map link. That is the best way for you to say, hey, I have the concept. I know I might need something, but I'm not sure. Contact your local coordinator for removal or fill, and they'll be able to help you walk through your project and where it is, what the status is, and whether or not you might need a permit from us. Hopefully that answered your question, Mark. And if there's any others in the chat, please enter them now or call them out if I missed something.
Charles, I believe that was all of the questions that were in the chat.
Okay.
So thank you for that, Charles. I appreciate it. And if you have if anyone has any other questions, just please put them in the chat or reach out to Charles directly. And so we will move on to our final session now, which is on funding for dam safety related work. Before we get into this final session, though, I want to mention that after the final session, we're going to have a poll question in the chat for future workshop topics. So just be aware that after the final session, there will be that opportunity for you to provide some feedback. And so with that, we'll turn it over to Adair. And Adair, please introduce yourself.
Good morning, everyone. My name is Adair Muth. I am the grants manager here at OWRD and happy to be here today. And let me start sharing my slides. Can you all see that? I'm gonna go with it.
I can see it, Adair.
Perfect. Thank you. I realize that a lot of you can't talk. Thank you for answering in the chat. Okay, so here to talk about some of our funding opportunities and specifically how they relate to dam safety. So just to orient you a little bit before I dive into that, wanted to let you know at OWRD, the section that manages grants is our planning, collaboration, and investments section. And the purpose of our section is to build partnerships and incentivize Oregonians to pursue integrated and innovative solutions for complex water challenges in an uncertain water future. And the way that we do this is the 5 items that are at the bottom of the slide below. And specifically in grants, we work on strategic investments. So currently, this is the list of our funding opportunities at OWRD. Today, I want to specifically talk about our feasibility study grant programs and our water project grants and loans, but did want to make you all aware of these other opportunities. You can find information about them on our website, and please reach out if you have questions about any of the other ones. But diving right in, our first grant program that I wanted to talk about is feasibility study grants. So the purpose of this program is to provide funding to evaluate the feasibility of a water conservation, reuse, or storage project. Those are the 3 eligible types. We offer this grant program on an annual basis. Applications are due each spring, typically in March. Those then go through process with a multi-agency review team, and the funding decision is made by our Water Resources Commission at their fall meeting. This year will be September. These grants do require a 50% cost match. That can be in-kind match, cash match, and we accept any other type of funding. So it could be other federal funding, state funding, anything except other OWRD dollars. So really the purpose of a feasibility study is to answer the question, should we or how should we proceed with a proposed project idea? You might have an idea, but you need a little bit more information, whether it's engineering, financial, geologic, regulatory. Again, it's really up to the applicant to determine what they need to investigate in order to determine if they should proceed with an idea for a project. And again, if that project is a conservation, reuse, or storage project, it is eligible. Related to dam safety work, I wanted to let you all know there's a bill in the current legislative session, House Bill 3364, that would add dam safety work as an eligible activity for feasibility study grants. So at this time, we cannot fund this work, unfortunately. But if this bill passes, we would be able to evaluate analyses associated with evaluating the safety of existing dams and analyses associated with evaluating actions to address safety deficiencies related to existing dams. We would be able to fund those activities with this grant program. This bill was proposed by Representative Helm and Owens, and my understanding is that it passed the House and is now headed to the Senate. If it passes, it would be effective this year, so these activities would be eligible in the next round of funding, which is anticipated to be announced this fall, and applications will be due in spring of 2026. Moving on to water project grants and loans. This is our funding opportunity that funds the actual implementation of projects. So feasibility study grants is looking at, is this feasible? Should we do this project? Water project grants and loans is the funding to actually implement it. So this program provides funding for water supply projects that meet in-stream and out-of-stream needs and achieve public benefits in 3 categories. This is a really key piece of this funding opportunity. The projects must provide public benefits in the 3 categories that are shown on the screen. So economic, environmental, and social cultural. There are numerous project types that are eligible for water project grants and loans: conservation, reuse, above ground and below ground storage, stream flow protection or restoration, and water infrastructure. Related to dam safety work, water project grants and loans could fund a project if the proposed project would provide new or expanded water storage, or if the proposed project would improve or alter operations of an existing water storage facility in connection with newly developed water. For water project grants and loans, we offer 2 funding cycles per year. The deadlines are in January and July. Those again go through application review with a multi-agency technical review team, and the funding decisions are made by our Water Resources Commission in June and December. This program also requires cost match, but only 25% cost match. Again, that can be in kind or cash match. And then really important is that these projects are scored on the public benefits. Statute outlines how these projects will be scored. And again, they're scored on those 3 public benefit categories: environmental, social, cultural, and economic. If you are interested in this program or have a proposed project idea, I always recommend that folks go on our website and look at the scoring criteria guide that's on the website, and you can see a picture of it here, because this outlines exactly how the projects will be evaluated. There are 6 questions per category. It's not expected that anyone would have public benefits in all of the questions, but there is a minimum score required for each category. So it's a good idea to read through that and see if your project is a good fit for this program. That was a lot of information. Always happy to talk with folks about project ideas and whether they're a good fit for our grant programs. The best way to contact us is through our email address, owrd.grants@water.oregon.gov. This goes to all of our grant staff, and we can provide you a more timely response. Also wanted to note, if you are interested in pursuing a project and you decide to submit an application during our open funding, when we have an open funding cycle, we offer pre-application conferences. And what this is you would submit a draft application to us. We review it. We send it to different folks in our agency who have expertise in that area. And then we set up a meeting with you, an hour-and-a-half meeting, to go through your application and provide you feedback. And really the goal of the pre-application conference is to help you submit a successful application. So really encourage folks to request that pre-application conference if you are interested in these funding opportunities. With that, thank you so much for your time, and I'm happy to answer any questions.
Thank you, Adair. So I think the best thing to do is wait and see if any questions are coming in is to post our poll question. And Adair, if you could just monitor the chat for the next few minutes in case something does come in, that would be great.
Yep, happy to do that.
Thank you. All right. Well, thank you, everybody. And as I mentioned, we plan on doing these again in the future, and we will, like we did this time, send out another notice that we'll be holding them. And I appreciate everybody attending, and I want to thank all of the presenters. This has been very helpful, and I look forward to future workshops. Thank you. Have a great rest of your day.